This is the second session, clustering the components. If you've done your background and assessed your current situation as described in the previous session, you will have identified potential gaps, bottlenecks, and barriers to successfully achieving your goals. You are now ready to get down to the next step of creating the practical part of your plan. We're going to do this by looking at how to arrange tasks into feasible workflows. In Chapter 4 of The Hobbit, Bilbo and the unfortunate dwarves are captured by goblins, chained together in the dark and deep mines of the Misty Mountains. This may indeed be your first reaction to the start of your practical plan, but remember that by being physically clustered together, it made it easier for the dwarves to stay together and escape. It was by getting detached from the group that Bilbo was lost. Of course, he found the ring as a result, but that's another story for another time. So let's think about the term clustering and what it means for us in terms of planning. The definition of the noun cluster is a group of similar things or people positioned or occurring closely together. There are three important parts of this definition for us: the group, the fact that they are similar, and that they are things. Just like a dance formation, where your aim is to form a coherent pattern without tripping over each other and being in time with the music, in order to successfully mobilize and achieve your goals, you will need to be able to identify groups of tasks and arrangements of similar tasks, cluster them together, and then string those clusters together into a logical flow. What we are looking at here is the when and the how of your project. When do tasks need to happen, in what order, and in what manner? We're going to look at three concepts to help us understand these concepts: groups, task clusters, and workflows. Let's first look at groups. Probably the most important grouping to be able to identify in your project is stage. This is the when of your project. What we mean here is at what time during the project should any particular task or group of tasks occur. The simplest, but by no means the only stage grouping, uses digitization as its reference points. In this case, in this example, before refers to any time before the start of the digitization effort itself, i.e. before imaging and transcribing. During relates specifically to the period of active digitization, and after is the period after digitization has ceased. Another common grouping uses start and end time of funding as its reference points. You can use anything that makes sense, and be aware that you may use different groupings that make sense for different stakeholders. There are many ways to arrange these tasks, and this is the how of your project. We'll look at two methodologies here. The first are task clusters. Task clusters is a term that was coined by the iDigBio team in their 2012 paper, 5 task clusters that enable effective and efficient digitization of biological collections. In the paper, the authors identify 5 major groups of tasks that are most often found in successful natural history digitization projects. They are pre-digitization curation and staging, specimen image capture, image processing, data capture, and georeferencing. Clustering as a general concept is an extremely useful way to organize the detail of the tasks and project stages into manageable tracts and chunks. Next, we'll look at workflows. Workflows are defined as the sequence of processes through which a piece of work must pass from initiation to completion. In simple ways, it is the way that you join tasks and task clusters together. And we're going to look at 3 different types of workflows: sequential, rules-driven, and state machine. Sequential workflows are simple and represent a unidirectional series of steps with a single start and end. The important part being that each task must be completed before the next one can start. In this example, the sequence is name checking first, photography second, data entry third, and proofreading fourth. Rules-driven workflows often also have an underlying sequential workflow as previously described. However, within each task cluster, rules and logic can alter the process and progress of the workflow. In this example, in the lower right corner in the photography task cluster, there is a quality check logic gate. If there is a problem with the image, it is discarded and the specimen goes back to be photographed. Only when the quality check has been passed can the workflow continue and the specimen be refiled. The last workflow example is called machine state. This is probably the most complex form and is most often found in machinery, industry and programming logic. However, there are parallels and uses in the natural history world. Here, the steps within each task cluster happen asynchronously, i.e. they are not necessarily performed one after another, but instead can be triggered by actions and states in previous steps. One state is assigned as the start state, and then based on a particular event, a transition is made from one state to another, and so on. If we take this example from Allard in 2012, let's assume that the photography department only has space in their laboratory for 60 herbarium sheets at any one time. The name checking task cluster can continue to prepare specimens, but not pass them along to the photography task cluster until there is space again. Meanwhile, the other clusters may carry on without being impacted. To review, in this section, clustering the components, we have looked at ways to arrange the elements together into feasible workflows. Groups, which are ways to divide a project into manageable stages based on criteria, for example time, allow you to assign milestones and mark progress. Task clusters specifically describe the most common natural history digitization tasks. Lastly, workflows allow you to connect tasks and task clusters in a logical sequence to describe actual day-to-day project working.